want to get you guys as much review time as possible, so we're going to try to get 7-1 and 7-2 done today. Shh. What happens is if we get it done today, then tomorrow will be a work and review day in class. So it'll behoove you to do all of your 7-1 and 7-2 homework. Now, if you look at your 7-2 homework according to the notes, it's only like 1 through 9, so it's not a huge assignment, okay? And it's extremely similar to 7-1, so there's not too much. So it's kind of just like a big homework assignment. Get as much done as you can tonight, and then tomorrow will be review and homework, and then there'll be I'll try to make it a pretty easy little quiz on Friday for Module 7. That'll give us Monday and Tuesday next week to review for the final, right? And there's a good chance your final will be an online final, just to be aware of that. Yes? You're going to be a lot louder than that, Adrian. More than likely it'll be 2 days. When I finally get down to writing it, we'll see. We'll see. If it ends up being 1, it ends up being 1. It's going to, guys, remember, so Mr. Richards is, the end of the semester behaves just like the end of the year. The end of the semester behaves just like the end of the year. So if you miss the last day of school, right, and there is a final that day, when do you make it up? Never, right? So don't miss next week, okay? It's very important that you don't miss that day because there will be no opportunity for makeup because Mr. Richards is requiring your grades could be 100% turned in the next day. Madeline.
Okay, so we're having a test on Module 7.
A quiz on Module 7 Friday, hope. Your final's on 5, 6, and 7. It's that unit. It's 5, 6, and 7. Okay? Unless you're in that boat that you've got, unless you're in that boat where you've got a very low grade that you want to bring up significantly, in which case you're taking a Module 1 through 7 final. That'll be your option next week. Stephanie? Your final's 5, 6, and 7. It's just a standard unit test, counts the same. If you want it to be something that counts as more, you're going to take one that represents 1 through 7. Last question that I'm getting started on it no matter what. Madeline. I'll do my best to absolutely. Yeah, I'll do my best. It should be. Okay, it's all about timing right now. All right. So, guys, right now, let's put all the phones away here. Right now, we're doing rational root theorem. So first of all, let's quickly go and open up your workbooks. You notice it starts off right away. It's something that you should actually be able to do. So 7-1 in your workbooks, please. We're going to do 1 through 4. Luckily, our internet came up during second period. You know, for some reason, this computer stopped like automatically filling in very quickly here. Like I have to wait. I have to like click around the screen. There is internet. Eventually, it'll load in my saved stuff. Come on. There it goes. See, it takes. I don't understand why it's taking so long to upload. Pretty much, right? It's been doing this for a couple weeks now. I don't understand what's going on. We should already know how to factor these. I'm not exactly positive why. Sydney, let's set up the conversation. I'm not sure exactly why they have this on here. Sydney, you're talking to yourself now. Okay. Let's go ahead. Number 1, how are we going to factor it? By what? Josiah? Grouping. There are 4 terms. So number 1, we've got 4x cubed plus x squared minus 4x minus 1. We're going to factor by grouping. Today's a fast-paced day, guys. Be ready to write fast and pay attention. Michael, what can I factor out of the first 2 terms? More than just x. How many x's can they both give up? 2. So I can factor x squared out. And I'd have 4x plus 1. So to change that sign, what am I going to factor to the second one, Alexa? Not just 1. I want to negative 1. I need to change those signs. Stephanie, if I look at this as two different sets, what can I factor out of each one of these? 4x plus 1. And I'll have an x squared minus 1. Samuel, let's see if you remember. This is what? No? Well, what is that right there? And what is that right there? So it's when you subtract things, you find the what? There, difference of squares. Good job. So this is difference of squares, and we're done. I'll take 45 seconds-ish. Whatever I feel is 45 seconds to pause. What? Oh, so you regrouped them. Yeah. So while you guys write, it'll take the amount of time it took for me to do this. I told you before that you don't have to necessarily go with the first and second term and then the third and fourth. You can actually rearrange it. So Martina said, let's rewrite it as this, like that. And then she said, out of the first two, I can factor out 4x. Out of the second two, factor out 1. Then I still get the same thing. She said that this is how she did it. There's nothing, absolutely nothing wrong. You guys can see you get the exact same answer either way. So that's fine. You don't need to write that one down. That's just an alternate path that she took, which is 100% okay. Number two. Gabrielle, what can we factor out of all three terms? X to the third. All of them can give up 3 x's. Michael, you okay with that? Cool. 2. Yeah, number 2. Sorry, there you go. X squared. So if I take out an x cubed, I get x squared minus 2x minus 24. Do you guys remember what I said when you have a trinomial? When you have a trinomial and your a value is 1, we don't have to do the x box. Alexa, you remember what we do? Add to what? Nope. Add to negative 2. Multiplies to negative 24. So adds to 2, multiplies to negative 24. We'll get that in a second. So go ahead and write that down because I want everybody thinking the same way. This will be the last step. Since our a value is 1, it adds to negative 2, the middle term, multiplies to negative 24. Leticia? What adds to negative 2 and multiplies to negative 24? Two numbers. One has to be positive, one has to be negative. Not sure? Tim, help her out. I heard you.
Negative 2 and positive 12.
Nope, that won't do it. They need to add to negative 2, multiply. And if we need to, we could sit there and start writing down 1 and 24. Tim said 2 and 12. What else multiplies to 24? I'll get you guys in a second. Gabrielle, I'll let you answer. 3 and 8. 4 and 6. Which one of these have a difference of 2? 4 and 6. So, Gabrielle, which one's negative, which one's positive? Negative 6 and positive 4. And there we go. Samuel, did you say wait? So it adds to negative 2. Right? So which one? So since it's got to add to a negative number, we got to find a difference, right? So it's going to be 4 and 6 have a difference of 2, and we want the negative one to be the bigger one.
So the bigger number.
Yeah. So whatever this sign is here, if our last sign is negative, in order to multiply to a negative, one has to be positive, one has to be negative. Then we kind of turn our attention to the center one, and whatever the sign is, that's what we want the bigger one to be because we, want it to win. Why are we doing what?
Why do we add it to 2 and multiply it?
Because what happens when you get that middle term, like I'm just going to redistribute, right? We'd get x squared, right? Plus 4x minus 6x, and those combined give me that negative 2 that I'm looking for. Okay? This is a recapture of last. That's why I'm going through it so quickly. And don't forget, if it's too quick for you guys to understand, please watch the video later. Okay? Like and subscribe. All that good stuff. Sydney, what can I factor out of every single term here? 3. What else? How many x's? Cubed. Correct, sir. And then I'd have x squared, a 6x, and a 7. Once again, our a value is 1, so Adrian, we need to multiply to what and add to what? What do we need to multiply to? And then what do we need to add to? Don't recall yet? Okay. Remember, when our a value is 1, we just want to multiply to the last, add to the middle. So we want to multiply to -7, add to 6. So what two numbers multiply to -7, which means one's positive, one's negative, and add to 6? Johnny? 1 and 7. Those will multiply to 7, right? And if I subtract them from each other, they're going to get to 6, right? So which one's positive? If I want a positive 6, the bigger number, Wonder. The bigger number takes that sign. Yeah. So it's going to be a positive 7. It's going to multiply to -7, Alexa. Multiply to -7. -1 times 7 is -7. -1 plus 7 is positive 6. This is, like I said, back in, you guys get 4 problems on your homework. I mean, if you guys open up your textbook, I don't know exactly. It'll be like 5 or 6. And once again, back in my day, this will be a full section, and it's like you're doing 50 problems like this, and that's why it just, the repetition. I would, if you want to get as good as me, honestly, it's about finding additional examples and doing them on your time. But who's going to do that, right, Sydney? All right, number 4. Number 4. Who am I getting? Let's pick on Dylan. Dylan, what am I going to factor out of each one? Remember, I want my a value. It'd be really nice if my a value is 1. Right now, it's -1. So what am I going to factor out of every term here? Negative x squared is 100% correct. That's going to turn that positive x squared. It's going to change that sign to -2x. That's going to be -8. I'll let you guys think about that for a second. We're going to go back through these in a second because the problems aren't 100% completed, just to warn you. And I apologize for not giving that warning ahead of time. You're going to have to squeeze a little bit more at the... You'll just squeeze them on this line. If you filled up that entire line, we can squeeze the answer here. Don't worry, it's not much bigger. Okay? So, here. What multiplies to -8 adds to -2? Josiah? Right. -4, +2. I'll get to that after everybody's done writing. Give them a few seconds. Read all about it. Guys, the actual, I didn't realize it till a second ago, which is why it came a little bit late. It actually says solve them. And whenever you're asked to solve something, you have to get an equals, right? But we've already done this, so it's a super minor step. Super minor step that we should all be comfortable with, right? So it equals 0. So remember, if you don't recall, super important, each one of these parentheses equals 0. So this one will give me x equals 1. X equals -1. Now, way back in the day, you guys were like, oh, it's just opposite signs. If 4x plus 1 equals 0, I'll do the work right here, but I'll put the answer up here in a second. If 4x plus 1 equals 0, how do I get x by itself? Subtract 1, divide by 4. That's that one. Okay. Madeline, you okay with that? Too fast? Are you sure? Okay. Yeah. Madeline? So these ones should be easy, right? So what's this one gives me x equals what?
I wasn't paying attention.
Oh.
I was trying to figure out something else.
Okay. Well, Florian? X equals -4. Flo, what's this one give me? +6. These ones here that don't have add or subtract anything, they give me what? 0. It gives me 0. If they don't have a plus or minus on anything, it's just x cubed or x squared or x to the 8 millionth. Okay, they're just going to give me a 0. Yeah. Yeah.
We're just switching the sign.
No, because that's not what happened here. We set them equal to 0. We set them equal to 0 and solve. For the ones where it's just an x plus or minus something, yes, you're just switching the signs. But if there's a coefficient on that x, we have to be careful. Okay? So then let's go with Yvonne. Number 3, we'd have, this one would give me what? -7. That one gives me 1, and this one gives me, it's not plus or minus anything, so it gives me 0. It's not adding or subtracting anything, it's going to give me that 0. Huh?
Even if I had the number in front of it, still be 0?
Well, let's look at it. 3x cubed equals 0. What would I do to start getting x by itself? Divide by 3, but 0 divided by 3 is 0, right? So that 3 it doesn't matter because you're dividing 0 by it, right? And then cube root, and you still get the same thing. All right. Samuel. No, haven't picked on. Jaden. Jaden, this one gives me x equals?
-2, x equals 4, and then x equals 0.
Yep. All right, 1 through 4 are done. Now we can actually get to the rational root theorem.
Those were switched. I thought it was x.
It is +4.
I know, but like in the parentheses, I thought it was x.
Oh, no, no, no. Because it had to add to -2.
I thought you said the bigger one is always positive.
No, I said whatever the sign is of the middle, which I deleted it.
Oh, I have it. I have it.
Okay.
Oh, okay.
It keeps the sign of it.
Would you rather have one hand with 10 fingers or one foot with 10 toes?
Hand. Otherwise, I'd have to. It'd be really expensive buying shoes for the rest of my life.
No, you could buy a pair of gloves and then you just
Okay. All right, guys. Rational root theorem. You've got the strict definition in the notes that you have. Where are they at? Oh. I'm going to steal yours really quick, Leticia.
I just know this would be a really weird game.
All right. Guys, taking a look at page 1 of your notes for 7-1. The rational root theorem, if a polynomial is written in the form a sub naught x to the n plus a sub 1 x to the m, blah, 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 then if, that's a huge if, I capitalized it and all. Then if the polynomial has rational roots, they are of the form q divided by p. Now, q and p, what are q and p? So let's go ahead. Yes, go ahead, Alexa.
Where q represents all factors of a sub n, and p represents all factors of a sub naught.
Correct. Apologize. All right, now, guys, this is not, q is factors of a sub n. P are factors of a sub naught. So a sub naught is not p. It's just an easy way for me to kind of point out to where they're talking about. Okay, and a sub n is not q. Q is factors of a sub n. This is going to be really easy. It just starts off with that technical looking definition. So what we're saying is if we want to factor something, so if we look at the first example, f of x equals 4x to the fifth
minus 2x to the 4th plus 30x cubed, and then minus 15x squared plus 50x minus 25.
Okay. And I said, hey, factor this, guys. Yeah, no thank you probably comes out. Now, you could actually factor it by grouping without too terrible amounts of difficulty. But we're going to use something called the rational root theorem. So what is my p, the way this works, and notice I should have given you a decent amount of room, a little bit of room, but it is going to take quite a few synthetic divisions. So leave room for that. How many roots does this have? You should know this from your quiz from chapter 6. This should have how many zeros? Tim? 5. Has the highest power. The highest degree is your number of zeros. Has 5. Okay? So that means I'll have to do, and this is going to be something, do not write while we do this problem until I say write. So until then, just focus, because when you're doing rational root theorem, there's a lot of times when you could get trial and error, and then you'll have to erase. So I don't want to make an error, have to erase, and then you guys wrote it down, you're like, now you have to erase. Instead, let's just skip to you getting the right answer on your papers. So first of all, let's do my p's. P are all factors of the first number. So all factors of 4. What are factors of 4? I always start with a plus or minus 2, 4, 1. There we go. What are all factors of my q? My q is what? 25. So 5. 10 is not a factor of 25. 25 and 1. Okay? So, you guys okay with that? Just saying factors? So then I write down now notice I put a plus or minus in front. Because isn't negative 2 times negative 2 also 4? Right. So I mean, I could get positive or negative factors. So now I write every possible combination of q divided by p. Every possible combination. So that's 1 over 1. 1 over 2. 1 over 4. That's right? So I'm doing every combination. So I've checked off. I've done every combination with 1. 5 over 1. It is 5 over 2. 5 over 4. 25 over 1. This is bigger, 25 over 2, 25 over 4. This is larger than any of your homework problems. This one here. I gave us lots of things to try. And if you guys want, like right underneath, you could be like, this is really 1, somebody said. This is really 5, and this is really 25, you know.
25 is the wrong one.
Oh, put it under the wrong one. Everybody laughs at me. You guys are so mean. You're bullies, I swear.
I'm telling you.
Okay. So, yes.
It's coming.
Okay, you're good. And now Josiah's got a point, even though he was wrong on this one in particular. Josiah's got a point. Sometimes when you do this, you'll end up with repeats. Like let's say there was a 2 in this section right here. You'd end up doing 2 over 2, but what's 2 over 2? 1, and you already wrote 1. Right? So there could be some repeats. You don't have to try multiple times or anything. All right, this is true, so why don't you guys take 45 seconds, write this down. There's no error here. But now we're going to skip into 5 different synthetic divisions. So you need to leave yourself room for 5 synthetic divisions. Well, actually, we're going to do it in 4, but now you're happy? Got to squeeze every drop out of that, huh, Sydney? It's important. I always call them Capri Suns. There were some missionaries that we had over to our house a bunch of times, and my mom always kept Capri Suns stocked in the fridge. And one of the missionaries was from England, and he'd always be like, "Mrs. Bates, can we have a Capri Sun?" Mrs. Bates, because of my mom. It was my mom. Mrs. Bates, may we have a Capri Sun? I was like, Capri Sun, yeah.
Missionaries? What kind of missionaries?
Mormon. I've never met a bad. I've never met a mean one. So, okay. Everybody's done writing, guys? Focus. Okay? Not yet, Yvonne? Tell me when. I'm going to start talking at you guys while you finish writing. So, guys, this could, remember, it's a big if. If there are rational roots, they are going to be one of these. How many rational roots do we have possible? 1, 2, 3, 4, 5, 6, 7, 8, 9, 18. Okay? Because it's plus or minus. Because it's plus or minus. Boop, boop, boop. Okay? There are 18 possibilities. So, we don't want to try all 18. But if worst case scenario, we end up running through all of them. That sucks when that happens. Okay? But we try our best to make good guesses at this. Now, in pre-calculus, you're going to learn some additional tools that limit our guesses. But there's always work associated with each one. So we're going to try some synthetic division. Right? I've got 4, -2, 30. Remember, we're going to do 4 of these. -15, 50, -25. Okay? Yeah. Well, I mean, this is fine because I didn't put my guess here. So if you start writing this, you're not going to be wrong. All right. So here's the thing, guys. Out of all these numbers up here, one of these, and since this is an example, it's going to end up working out. At least one of these gives us a 0 at the end. What number would you like me to try? And I want you to think about it. Try to think of these numbers, and some of them are fractions. If I plug them in, but this always drops down, so that'll be a 4. When I put it in here, I will get a 0 at the end. Samuel. 5 halves. Okay? Let's see what happens. So this is where you pause and you watch for me to try, okay? I'm going to try 5 halves. 5 halves times 4 is 10. Okay? 10 minus 2 is 8. 5 halves times 8 is 40. Not 40, it's 20. That's 50. Okay? 5 halves times 50 is 125. That's going to make 110. 5 halves times 110 is 275. Now, at this point, so when you guys are trying them, it's getting too big. At no point am I going to be able to bring myself back down to a 25. So at this point, I'm going to give up on this one. 5 halves ends up giving me too big of numbers. So, Sydney, you had a guess. I warned you to not write because I'm going to be deleting as I go until I get one right. Yes? I think so. So, okay. 1/2. Sydney, you didn't tell me your guess. So I'm going to have to go with what other people say. 1/2. Okay. That's going to give me 2. 0, 0, 30. Half of 30 is 15. 0, 0, 50. 25, 1/2 works. Okay, so you guys can write that one down. Yes. Yes. The opposite sign of it, though. Well, because now I've found one of them, but remember, as Tim said, we're going to have 5 solutions. I've found one of them. But they get smaller. They get smaller, okay? So, for now, fill this one in. Question.
You have to have 4 solutions.
We're going to have 5 solutions because this thing was to the 5th. So 5 solutions. No. which is why I'm waiting. Okay? No, we are not going to write the big full thing again. We can use, this is important to make our life easier, we can use what's called, and I told it to you last section, the depressed polynomial.
Oh yeah.
We can use this. Yes. It is depressed. It's been shortened down. Okay? So we can use the depressed polynomial. So if we want to make room for this, we can squeeze, most of you I think can squeeze one more line below this on your sheet maybe. You could squeeze one line below. Adrian, no? Okay. So if you can't squeeze one line below, you're going to rewrite this line like up and to the right. I have the luxury of being able to fit another line below. So what I do is I put another little box right here, and I'm going to try again, but with these numbers. Because I have 5 solutions, and I've only checked 2 so far. Hmm? Yeah. So if, let's take a look really quick at last. Don't write this down, folks, okay? Let's say we had, I don't know exactly, Sydney, but let's say we had x cubed, there we go, x cubed minus 8, right? Last section. And we said, well, that's x minus 2 times x squared plus 2x plus 4, right? So what that would have been the equivalent of doing is if we tried 2 in here, right? Like right here, we would have put 1, 0, 0 because of the placeholders. Are you okay with that or no? Let me show you. Quick sidebar. Let's say we said, what's x cubed minus 8? And we're going to try 2. So 2, that's 1, that's x cubed. 0x squared, 0 x's, and then we had a negative 8. Right? Drop down the 1. 1 times 2. Add. 2 times 2. Add. 2 times 4. So this is my depressed polynomial. What is it? X squared plus 2x plus 4. So if I try this factor, I get something that still is the next piece lower in it. I broke it down to something smaller. Okay? So this 1/2 broke this down into something smaller. What is that something smaller? It's this. So I'm basically just like chunking it down until I get all the pieces. I found one piece. One piece is x equals 1/2. Bless you, Tim. Oh, you're stretching? I thought you were about to sneeze. You looked like you were about to. Okay. All right, so once again, we're not going to write this down until we find the right one. Let's figure out a number that's going to work. Huh? 1 over 1. Well, so 1? You want to try 1? Now, Josiah, I think, said something very intelligent back there. What'd you say? It's going to have to be negative. It's going to have to be negative. Because if I do 4, right, it's just going to keep on adding. I'll get 4, add it, 30, add it. I can't get 0 unless I get a negative. We know what this number has to be. Johnny pointed out earlier. This number is going to have to be negative 50. That's my goal. Because I need it to be 0 at the end. So this needs to be a negative number. So we can try negative 1. So once again, we're not writing. 4 times negative 1 is negative 4. Right? Add negative 4. Negative 1 times 4. Negative 4 is positive 4. 34. That's not going to give me a 50. Negative 5. Negative 5 times 4 is negative 20. I think that's going to get too big too fast, right? So negative 2 and negative 4 are not up here as my options. Negative 1/4. So negative 1/4, so running through it, that'll give me a 2. But then when I drop the 2, 2 times negative 1/4 is going to give me a fraction, right? And then I can't ever start getting a fraction and then multiplying, it's not going to go away. Negative 5/4. So same thing's going to happen. I'll get negative 5. But when I get down here, that's going to give me a fraction. I can't have fractions. After I multiply, I can't have fractions. Maybe negative, I think it's going to have to be over 2. Maybe. Try negative 5/2. I'm just guessing. Okay, so that's going to be negative 10. That's going to be positive 25. Positive 25, but that gives me 55, and I can't divide 55 by 2. That's not going to work. I said this is harder than anything we've got. Yes? Negative 25 over 2. Okay? Negative, this is, I mean, I put this example in the notes to show that sometimes it takes a lot of guesses. Negative 25 over 2, this is going to be negative 50. Okay? So negative 50. That's negative 625. Keep going, it'll work out. I did. Negative 25 over 4? No. I'm wondering whether or not I picked something that actually only has the one answer. Well, it'll be numbers, and that's not going to work out. It's like negative 1/4, but that's just going to be negative 1. What's up? Sydney? I thought you were... Negative 1/2. Did we try that already?
We have 1/2 on top.
Oh yeah, but nothing says we can't have negative 1/2. So that's negative 2. That's 1. That's going to give me an odd number. It might be that there are no other. So have we really, like, first of all, there are no more, we can't get another positive in here. So we're down to 9 options, okay? We've tried pretty much all of them, right? Which means, we didn't do which one you want to try. Just negative 25? It's just going to get gigantic, right? It's just going to get gigantic. There are some we can kind of toss out. Yeah. I have a strong suspicion that we found the only rational root. That means the rest of the solutions are irrational. This is the rational root theorem. None others worked, so we've probably found our only rational solution. Negative 5? Negative 5 would get negative 20. That's going to give us negative, it's getting too big, I think. Okay. We did not try it, but okay. What? No, not in real life. In your homework, it's going to be rare for this to happen, Samuel. No, this is pretty common. Okay. All right. Shh. Okay. All right. So x equals 1/2 is our only solution. We only had to do it once. Check factor by grouping? I can do a quick one. This is not for you guys to write down, though. Okay. I could plug this into the internet to see, but it'll take too long for me to type it, and we have very limited time here, folks. So factoring by grouping, let's just try it really quick. I'll take out 2x to the 4th. I have x minus 2, right?
What?
I have 2x minus 1. If I take 2x to the 4th out of the first 2, right? I take 15x squared. I'll have 2x minus 1. I take out 25. I'll have 2x minus 1. Take out 2x minus 1. I have 2x to the 4th plus 15x squared plus 25. X box. Top, I'll have 50x to the 4th. Bottom, I have 15x squared. Multiplies to 50, adds to 15. 10 and 5. Okay? So we'll have 10x squared. Okay? 10x squared and 5x squared. Okay. Box. What's up, Alexa? Huh? No. When you add them, the exponents don't change. Okay? So top I'd have 2x to the fourth. Here I'd have 25, 5x squared, 10x squared. Factoring, I have 5. I have x squared. Factoring, I have x squared. Factoring, I have 5. Nope, wait, there's something wrong here. No, I'm good. Oh, this is 2x squared. There we go. All right, so I'd get x squared plus 5 times 2x squared plus 5. Both of those have imaginary solutions, so there are no more rational roots. If I solve this, you guys should remember this is the next section, so you should pay attention. Okay, if I solve this, I'd get x squared equals negative 5 square root, and I'd have x equals I square root of 5, plus or minus. Imaginary. So remember, the rational root theorem only finds nice fractions and whole numbers. It doesn't find those. And this one would end up being the same thing. It'll just be over 2. Huh? No, so it does, because remember right here, I've got this one I haven't worked with. 2x minus 1 equals 0. Add 1 to both sides. Divide by 2. Okay? So, all right. Going forward. All right. All right. The same root, just so you guys know, the same root could be used. So let's say we were trying this and we were like, 1/2 worked, and it all worked out. You could try 1/2 again. You could have multiple of the same one. When that happens, this is that little side note at the bottom of that note. When that happens, what I'd write is x equals 1/2, and then I write the word multiplicity, and then however many times it actually happened. So if this were true, I would have written x equals 1/2 multiplicity 2. In other words, 1/2 worked twice. Okay? All right. Time purposes wise, we're going to hold off on the workbook. We're going to hold off on the workbook for time purposes. The next part of the notes on 7-2 will be the next part of the notes on the back page here. Seven 1 and 2. But tomorrow you're gonna get to work in class, but I'll be answering questions. But that's gonna count as your review as well, just to warn you. Okay. All right. They always are laughing. All right, guys. So the next part, if I tell you, I say write a polynomial of least degree with the given roots. And the given roots I give you are 5, -2, and 3. What this means, you're just working backwards. So we found an x equals. So I want you to put those, remember the parentheses in your mind. X equals 5, -2, and 3.
Oh, so you can do. I know this.
So your first step would be to write that. Once you get comfortable with these, you do not have to write that. Now, if we were finishing our factoring and solving problems, and this was our final answer, what would have been the step right before it, Josiah? Yeah? I don't need parentheses yet. Whoop. Okay. Martina, you okay with that? Okay. That would have been the step before it on previous problems.
Yeah.
Yes.
Those we are answering.
No. We're getting to the point where we've written a polynomial of least degree. Patricia, do you remember what would have been right before this? No? Samuel? Amanda? Parentheses? Uh-huh. Yeah. Yeah. So it would be all three of these multiplied by each other equaling 0. That would have been the step before. So now this is our next step. We're building the polynomial. And now we're simply going to distribute and simplify. Distribute and simplify. So take the second two, leave the first one alone just so that way distribution is easier that way. We get x squared minus 5x. What are you sorry for? You're fine. Gabrielle, you're fine.
I know.
I'll give you a second to write when I'm done. Yeah. Yes, from here to here I combine like terms. And we'll have, that is our polynomial of least degree. So I'm going to give you guys a second to write, read, and digest.
Okay.
What's up? Oh, you're good? Okay. You'd be a meerkat.
I'd be an ant because look, I was walking around, bruh, and somebody, hopefully me, like as a person, dropped a big talkie on the floor, bro. I'm an ant. That's like paradise.
But remember, the worker ant's not going to eat it. He's just going to take it to the queen.
Yeah, why is he a meerkat though? What does that mean?
Oh, I just feel like
my own
I feel like if something occurs in class, that Sydney's always the one to be like,
Okay, what would I be then?
I don't know, Sam.
What would I be?
Annoying.
How was-
All of
if
you
I was a meerkat,
said annoying.
if I was a meerkat,
Is that funny?
Well, you guys want me to come up with it on the spot. I can't. I've given Sydney some serious thought here. No, I haven't. I just.
I don't even know what you're talking about.
Okay, guys. By the amount of talking, I'm assuming quite a few of us are finishing or finished. So I'm going to open up the next, Sydney. Opening up the next 30 seconds for if you don't understand anything I did here.
All you did was distribute.
Yes, Samuel.
You just review it like, no, like, yeah, you just review. Can you do it in any order?
Yeah.
So the answer to this is you do it backwards.
Yep. Yeah.
That's one thing that.
Samuel, you'd definitely be some sort of bird. All right.
If I was an animal, what would I be?
I said it. Meerkat. All right.
Why a meerkat? I don't.
Just because you're not happy with my answer doesn't mean it's not my answer. Okay. Guys, I'm going to jump to the last example. I'm going to jump. Well, so that one, so the one right before it here, let me show you. I won't, I'll start the next one. I'll start the next one, but the roots are plus or minus square root 2, plus or minus 3i, and 1. Okay? So this would give us x equals square root 2, x equals negative square root 2, x equals 3i, x equals negative 3i, x equals 1. So it gives us a lot. Because the plus or the minus. So we get x minus square root 2 times x plus square root 2 times x minus 3i times x plus 3i times x minus 1. You guys could work these out. That is only starting it. What are these, guys? Think of the word again, please. Hopefully somebody remembers it. It's the difference of squares, which means they're conjugate pairs. They are conjugate pairs, so there's no middle term. It's just x times x, which is x squared, minus square root 2 times square root 2, which is 2. This is x times x, which is, that should have an x squared. Sorry about that. X times x, which is x squared, negative 3i times positive 3i, which is plus 9.
Why would it have I?
Because I squared is negative 1. That's what changed it from a positive 9 to a negative 9, or negative to a positive 9. Yep. So we're not getting that last example in because people are panicking. No, not because they're talking. Okay. This is what happened, folks. This is what happened, Sydney. X times x, x squared.
Okay.
Distribute. Plus square root 2x.
Okay.
Minus square root 2x. Those cancel.
Yep.
Minus square root 2 squared, which is 2. Because the square root and the square root cancel. Right? Okay. X squared plus 3ix minus 3ix. Those cancel. Minus 9i squared. I squared is negative 1. Turns it to a positive 9.
Oh, okay.
Okay. All right. I will do the last few examples in class tomorrow, but it does count as our review. Do just as much as you can of 7-1. You should be able to finish 7-1 actually. Check it out. Yeah. I started 7-2. It'll finish up tomorrow. Have a good day.